So here, let's do some more examples with these compound probabilities. So the probability of 2 face cards. Remember, there are 12 face cards. So that is 12 out of 52. And this said without replacement, so I'm not going to put the card back. So now instead of there being 12 face cards, there are 11 face cards and they're only 51. We're going to type this in. You can type it in all at once and go ahead and reduce it down, or you can do it in steps. I'll write out that middle step just in case you feel more comfortable with that. But we do want to get down to the final answer of 11 over 221. So very similar, this next one, the probability that we first get a jack, there are 4 jacks out of 52. And then the second one is a face card. Remember, we started with 12 face cards, but we pulled out a jack. It is a face card. So we're still left with 11 face cards and 51 total. Again, I'll show that middle step. You don't have to if you don't want to, but we do need to get down to that final answer. And I need to see, I need to see your setup and your answer. If you want to show that middle step, you're more than welcome to, but we do need to have the setup, whatever you typed in the calculator, and then whatever your final answer is. The next one's very similar. We're going to do another card, so go ahead and hit pause, try this next one out, and then you can come back when you're ready. So in this one we wanted hearts. There are 13 hearts out of 52 cards, and again, it's without replacement. So I'm going to be reducing down each time, and I'm going to do this 5 times because I was drawing out 5 cards. Now this one, some calculators cannot reduce down, so I am not going to reduce it down. It's so large that calculators have trouble with it. So if your calculator is giving you that weird scientific notation, the one with the E, just type in the numerator, get that answer, type in the denominator, get that answer, and you can just leave it. You don't have to reduce them down when they get this large. So our next example is the same sort of idea, but now I've given you the probability of rain, and sometimes it just throws people for a loop when I just flat out give you the probability. You don't have to think about what it is, it's just there. So in November, the rain in this valley area lasts a certain day, and we're going to say it's unconditional, so just straight out. On any given day is 50%, 0.5. But the probability on the rain of the day following a rainy day is 80%. So the first day is 50%. If it's a second day of rain, it's 80%. And third day would be 80%. And fourth day would be 80%. And the probability of rain on a day following a non-rainy day is 30%. So we've got these 3 numbers that we're going to use. So we want to know first the probability of rain on 3 randomly selected consecutive days. So that means we've seen consecutive before. That means we're going in order, or they're side by side. So maybe on the 7th, 8th, and 9th day, those ones grouped together. So the first day, the probability is that 50%. But remember, the probability of it raining the next day following a rainy day is 80%. And that would be for the second and third day. I'm just going to type that in my calculator to give me 0.320. All right. Next one, the probability of rain on day 1 and 2, but not on day 3. So we want rain, then not rain. We know the probability of rain the first day is 50%, that 0.5. The probability of rain the second day is 0.8, because it's 80% after it's already rained. The not rain is the tricky one. We actually don't have that number yet. We know the probability of it raining from up here was 80%. So the probability of that rain was 0.8, 80%. And then remembering back to nots, that's going to be 1 minus the 0.8, so that's 0.2. So that's what I'm going to put right there for the not rain. Typing this in my calculator, that's going to give me the answer of 0.080. And I'm just going out to that 0 because it said 3 decimal places. If you put 0.08, I am not going to count that wrong. All right, see here. The probability that we're going to rain on 4 days in November. So we would have rain, 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 and rain. Given that it did not rain on October 31st, so the last day in October. So it didn't rain that day. So this is the one number we haven't used, the probability of rain following a non-rainy day. So it did not rain, and then we want to know that it did rain is 0.3. The probability of a rain after rain, remember, is that 0.8. Or you can put zeros in front of those. I was using zeros. You can put zeros in front of all of them. It doesn't change the problem. Typing that in my calculator. That's going to give me 0.15, and I want to round it to 3 decimal places, so 0.154.